This is Bob Capetta from the University of Illinois at Chicago, and this lesson is on the quotient rule. So if we have two functions dividing, how do we find the derivative? You might think you just divide the derivatives, but no, it's not quite that simple. The rule is as follows. The derivative of f of x divided by g of x, f prime of x times g of x minus f of x times g prime of x divided by g of x squared. It's a little hard to remember. I prefer this version, which looks a lot like the product rule. The derivative of u over v, they are both functions of x, is u prime v minus uv prime over v squared. So this is the model I will use in this discussion. So our first example is the derivative of 3x plus 5 over 2x minus 1. The derivative of the top is 3, the derivative of the bottom is 2, and no, we do not simply divide the derivatives, we have to use the quotient rule. So we'll define u as 3x plus 5. We'll define v as 2x minus 1 and find the derivatives. If u is 3x plus 5, u prime is 3. V is 2x minus 1, v prime is 2. So our rule is u prime v minus uv prime all over v squared. That's what we're going to use. So plugging in those values, u prime v, 3 times 2x minus 1, minus uv prime minus 3x plus 5 times 2, all divided by v squared, all divided by 2x minus 1 squared. Distributing, so be careful with the algebra here. 3 times 2x minus 1 will give me 6x minus 3 for this parentheses, and this one would be 6x plus 10, but we've got to subtract those, so be careful there. So indeed, 6x minus 3 is the first part minus quantity 6x plus 10. Be certain to distribute that negative sign. It'll become minus 6x minus 10. 6x minus 6x is gone. Negative 3 minus 10 would be negative 13. So all that's left upstairs is negative 13, and downstairs is 2x minus 1 squared. So that's our first example of the quotient rule. Look at another example. We have the derivative of e to the x over x. So u will be e to the x, v will be x. We'll find the derivatives of both of those pieces, and they're not terribly challenging. The derivative of e to the x is e to the x. The derivative of x is 1. Our quotient rule, u prime v minus uv prime all over v squared, u prime v e to the x times x, minus uv prime minus e to the x times 1, all divided by v squared, all divided by x squared. So again, there's our rule. Plugging that in, u prime v e to the x times x minus uv prime e to the x times 1 divided by v squared divided by x squared. So rewriting this, that's x e to the x. This piece is e to the x, so my final answer is simply x e to the x minus e to the x over x squared. Do not divide out the x's. This is not a factor. This piece is a term, this piece is a term, and you do not cancel terms, you only cancel factors. It must be multiplication between everything if you're going to divide top and bottom. Our next example is the derivative with respect to x of x squared plus 5x plus 2 over e to the x. U is x squared plus 5x plus 2, and v is e to the x. The derivative of x squared plus 5x plus 2 is 2x plus 5. The derivative of e to the x is e to the x. And of course we have our quotient rule, which is u prime v minus uv prime all over v squared. So the algebra here is going to get kind of challenging. U prime v, 2x plus 5 times e to the x, minus uv prime minus that thing, x squared plus 5x plus 2 times e to the x, all divided by v squared, all divided by e to the x squared. And then we have to distribute. Or better yet, let's factor an e to the x out of this piece. Let's factor an e to the x out of that piece. Because if I can turn e to the x into a factor, then I can divide the top by e to the x, I can divide the bottom by e to the x, and make this a little simpler. So indeed, extract an e to the x here and here to enable us to simplify that fraction. So if I factor an e to the x out of the first piece, I'm left with 2x plus 5. If I factor an e to the x out of the second piece, I'm left with minus the quantity x squared plus 5x plus 2. So you see how I've done that. E to the x factored out of the first piece, leaving this. E to the x factored out of the second piece, leaving this. I've rewritten e to the x squared as e to the x times e to the x, so you can see this e to the x is now a factor. It's multiplying that whole piece. Divide the top by e to the x, divide the bottom by e to the x to get this. We're still not finished because, of course, you can simplify the numerator. Subtract x squared, subtract 5x, subtract 2, get like terms to get our final answer. So this is the last line of the previous slide. Again, subtract x squared, subtract 5x, subtract 2. And what do we have? Negative x squared is the only x squared piece. 2x minus 5x would be minus 3x. 5 minus 2 would be plus 3. So negative x squared minus 3x plus 3 over e to the x, with some fairly challenging algebra involved in doing the quotient rule for that problem. Our next example is the derivative of x squared over the natural log of x. U will be x squared, v will be the natural log of x. So u prime, the derivative of x squared, is 2x. V prime, the derivative of the natural log of x, is 1 over x. So our quotient rule, u prime v minus uv prime over v squared. U prime v, 2x log x, minus uv prime, x squared times 1 over x, all divided by v squared, all divided by log x squared. But you'll notice that x squared times 1 over x can simplify. X squared times 1 over x just becomes x. So we get 2x log x minus x over log x squared. You could, in theory, factor an x out of both pieces in the numerator, but nothing cancels, so I don't really see an advantage to doing that. I think this answer as written is perfectly fine. Okay, our next example is the derivative of x cubed log x over 3x minus 2. So yes, we will use the quotient rule. U will be x cubed log x, and v will be 3x minus 2. And getting v prime is not a problem. V prime is the derivative of 3x minus 2. V prime is just 3. But little u prime is going to require the product rule, because I have to take the derivative of x cubed log x. So to do this, we're going to go ahead and use a different u and v and use the product rule. Remember, the product rule is the derivative of u times v is u prime v plus uv prime. So I'm going to call it capital U is x cubed, and capital V is log x to try to find the derivative of this. Capital U is x cubed, so capital U prime is 3x squared. Capital V is log x, so capital V prime is 1 over x. To get the product rule, it's u prime v, 3x squared times log x, plus u, x squared, v prime times 1 over x. What happens there? X squared times 1 over x is simply going to become x. So that this derivative of x cubed log x simply becomes 3x squared log x plus x squared. And that needs to be put up here for the derivative of little u prime, because that is going to be what we're going to need to complete the quotient rule. So we put that in there. So now we have u, v, u prime, and v prime for the quotient rule. And we remember u prime v minus uv prime all over v squared. And be careful with the algebra, it will get challenging. So here we go. There's our quotient rule. U prime v minus uv prime over v squared. U prime v, this whole thing, 3x squared log x plus x squared multiplied by 3x minus 2, minus uv prime, x cubed log x times 3, all over v squared, all over 3x minus 2 quantity squared. So our next challenge is to multiply these binomials. 3x squared log x times 3x would be 9x cubed log x. 3x squared log x times negative 2 would be negative 6x squared log x. Distributing this way, x squared times 3x is 3x cubed minus x squared times 2, 2x squared. No need to distribute over there. That is just going to be minus 3x cubed log x. So again, doing the distribution, we see 9x cubed log x minus 6x squared log x plus 3x cubed minus 2x squared minus 3x cubed log x. Now looking at this, is there any way for us to simplify it? And what you've got to notice is this is 9x cubed log x, and we are subtracting 3x cubed log x. 9x cubed log x minus 3x cubed log x would give us 6x cubed log x. So after we do our simplification, we can write it this way. We have 6x cubed log x minus 6x squared log x plus 3x cubed minus 2x squared. And you will notice if we wanted to factor the numerator, we could. There's an x squared here, there's an x squared here, there's an x squared here, there's an x squared here. We have at least an x squared in each of these four pieces of the numerator. We could factor out an x squared. However, it doesn't cancel in the denominator, so I don't really feel it's required to simplify. I believe that this version is adequately simplified. And that will conclude this lesson.